In this video, we're going to be looking at June 2024 A-Level Pure Maths Paper 2. Right, let's get on and solve it. Number 1 says the extension y of an electric string varies directly. So we have y, which is varying directly as the magnitude force F. Right, so now we have to remove the variation sign. So when we're removing the variation sign, it's going to be y equal to kf. So we're required to express f in terms of y. Right, so first thing first, we have to find the value of k. So if you want to find the value of k, you have to substitute, you have to use the information that you're given there. We're given that f is equal to 6 and y equals 0.45, right? So we're going to substitute. So y is 0.45 and f is what? 6. So it's 6k. So what is k? K is equal to 0.45 over 6. Right. So what is 0.45 over 6? The answer is what? 3 over 40. So k is equal to 3 over 40. So our equation is now y equal to 3 over 40 f, right? And then the next thing, we're supposed to make f the subject because the question says express f in terms of y, not y in terms of f. So you multiply both sides by what? By 40 over 3, and this side by 40 over 3. So at the end, our answer will be what? So these ones are going to cancel. So therefore f is equal to 40 over 3y. Right, we've answered the first part of the question. We get our 4 marks for that. Then part B. Part B requires to find the value of f when y equals 0.2. So we're just substituting. In place of f, we're replacing y with what? 0.2. So 40 over 3, you punch in your calculator. 40 over 3 times 0.2, what you get? 8 over 3. So therefore f is equal to what? 8 over 3. You underline your answer. Moving on to the second question. Right, the second question, we're going to solve it on the PDF itself. Right, what does it say? It says that we're supposed to copy and complete. Right, so since our dot there, maybe let me do this. Right, so that, yeah, since our dot there, this one is the composition function. So it means that in order to get, right, so first thing first, what you're supposed to do is you just label, this is G, this is F, this is H. Same applies here, do the same thing, G, F, and H. Right, so the reason why for the first row we got X, because they say G of G. Then the second part, the second part, G of F is X minus 1. Then G of H is X plus 1. So since we're filling in the tape, we're supposed to find what? We're supposed to find F of what? F of G. Okay, so F of G is what we're looking for here. So f of g here, what does it mean? It means that go to g and replace the value of x with the value which is in f. So what are we going to have? Is it our g is x and our f is what? Is x minus 1. So in place where there is an x, right, so what are we saying? We're saying that where there is an x, because we're saying f of what? Of g, right? So where there is an x, is it our f is x minus 1, right? Our f is x minus 1. So, but in place of x, this x, replace the value of x with the value of g. But what is g? G is x. So our answer becomes what? X. It still goes back to x minus 1. So this one is what? X minus 1. I hope I tried to explain that one for you. Right, then the next one is f of f. f of f. When I'm saying the next one, I mean this one. Yeah, that one. Okay, so f of f in this case is what? So we're saying that is it f is x minus 1. F is x minus 1. And so maybe first thing first, let's write our x minus 1. X minus 1. And then in place of x, where there's an x, put the value of f. Of which what is f? F is x minus 1. Where there is an x, we're putting x minus 1. But value after x, what is following? It's minus 1. Okay, so this whole value of x has been replaced by x minus 1. Like that. Okay, so at the end, our answer is going to be x minus 2. Okay, x minus 2. Then the next one is what? H of f. H of f. Right. So what is h? H is x plus 1. And so in place of x plus, or in place of x, we replace our x with the value of what? Of f. We input where there is x, we input the value of f. But what is f? F is x minus 1. So equal to x minus 1. But after x, what is following after x? It's plus 1. So x minus 1 plus 1 is x. So we're going to get an x there. All right, then the next one is what? X. The next one is h of h. H of h. Right. So what is our h? Our h is x plus 1. Then in place of x, we're replacing x with the value of h, of which h is x plus 1. So where there is an x there, we're replacing this x with what? With x plus 1. Okay, this x now is x plus 1, and then this plus 1 will come down as it is. Right, I'm saying that this plus 1 is this one. It will come back as it is. Okay, so at the end, our answer is going to be what? X plus 2. So here our answer is x plus 2. Right, we get our 2 marks. Then to use the identity, use the table to find the identity element. The identity element, it respects the following. It respects that okay, maybe let me just do this. No, let me use the next page actually. All right, this is what happens with the identity element. Is it we're at number 2b and 2b item 1. The identity element, it does this. A star E is equals to A, which is equal to E star A. So suppose we have an element A. If A multiplies with identity element E, you are supposed to get A. Or even if the identity element multiplies with A, you're supposed to get A. So coming back here to our question, if you go to the table, let's check the value, whereby if it multiplies any element, you get that very element. Okay, right. So if you check x, if x and x gives us an x, x and x minus 1 is giving us an x minus 1, then x and x plus 1 is giving us a what? An x plus 1. So our identity element in this case is what? Is x. So therefore in this case, E is equal to what? X. Right, then the inverse element of each set. Right, then the inverse element, it does this, and it follows this law. Item 2 follows this law. It says A star A to the power minus 1 is equals to E. If you multiply an element with this inverse, you're supposed to get the identity element. So the key here is, let's go wherever is it we have identified that our identity element is x. And so let's go wherever there's an identity element. So let's go to the first row. The first row identity element is x. For the first row, identity element is x. So therefore, what does it mean? We're saying that if x, this x operates with that x, they're getting an x. So which means the identity element of x is what? Is x. So we can say, maybe we can come this side. Yeah, we come this side and do this. Maybe just write element and then identity. Element identity. So which elements do we have? We have x, we have x minus 1. We're doing this for order. Then we have x plus 1. So we have discussed that the identity, sorry, I mean the inverse element, not the identity element, the inverse element. Okay, so inverse. Okay, so what is the inverse of x? We've discussed that the inverse of x is what? Is x. Right, let's go that side and check. Right, remember we said if you want to find the inverse of an element, you have to go to the what? To the identity element. For our second row, which one is the identity element? It does not change. Identity element is x. Okay, so if you operate x minus 1 with x plus 1, you get what? X. So the identity element of x minus 1 is what? Is x plus 1. Right, so we come here and write our x plus 1. Right, then let's go to x plus 1. Right, with x plus 1, what's happening there? We are saying that if you operate x plus 1 with x minus 1, you get x. Really, the key here is this one, our identity element, this one, this x. X is our key there. Okay, all right, maybe let me just highlight it so that people, yeah, I'm highlighting my identity element. All right, so since our identity element is x, we're saying that if you operate x plus 1 with x minus 1, we are getting x. So meaning that the inverse of x plus 1 is x minus 1. So the inverse of x plus 1 is x minus 1. X minus 1. So we're done with the second part. Why set S is not a group under other function composition. Right, so if you notice on our Kelly table here, something is happening on our Kelly table. We have new elements that were not there. For example, for a group to be a group, it is supposed to satisfy 4 axioms, and so already the first axiom has been affected. The closure one is this group is not closed because we are seeing foreign elements in our Kelly table. Which foreign elements am I talking about? I'm talking about x plus 2, because from here we don't have an x plus 2. I'm talking about x minus 2. From here we don't have an x minus 2. So that is our reason. You write that set S is not a group under function composition because it is not closed, or it does not satisfy the closure property. Yeah, so you can just write it does not satisfy the closure property. Maybe you can just have an example there. If maybe the question wanted you to have an example, you can say, for example, h of f is equal to, no, maybe, sorry for that one. For example, even h of h is equal to x plus 2. Okay, it's just an example which is indicating why we are saying that it is closed. Right, okay, right, let's move on to our next question, number 3. Let's go to number 3. Okay, so what does number 3 say? Number 3 states that it wants us to find the shaded region. It wants us to find the area of the shaded region. So that is what we want to do here. Let us find the area of the shaded region. So what do we have? We have a rhombus AOBC, and ADC is an arc of a circle, center O, radius R, and subtends an angle 2 theta at O. The shaded region is bounded by the arc ADC and sides AB and BC. Alright, so we know the properties of a rhombus. A rhombus, the opposite angles are equal, all sides are equal. So how do you find the shaded region? If you want to find the shaded region, in this case, we have to find area of this whole shape, and then we remove this area, this one that I'm shading. This is the area that you want to remove. Okay, maybe let me just highlight it here for you. Yes, so we want to remove this area. This is the area that you want to remove. We're removing all of that area. Yeah, so this is the area that we are removing. We're removing that area, right? Of which the area that we are removing is a what? It's a sector, right? Yes, we have a sector there. So we want to remove that sector. So first thing first, let's write down the areas. How do you find area of a rhombus? Area of a rhombus. So area of our rhombus is OABC. Of OABC, the formula is AB sine theta. Okay, so our A and B, is it all sides are equal? So this side is R and this one is R, meaning that one is also R and that one is R. So A and B is R. So R times R is what? R squared. So it's R squared sine. What is our angle? Our angle is 2 theta, sine 2 theta. Right. Then next we have to find area of the sector. Area of sector is sector what? OADC. Sector OADC. So what's the formula? It's half AB. No, formula for a sector is half R squared theta, actually. Half R squared theta. So our R is R, so it's half R squared. Our theta is 2 theta. Then we cancel. So at the end, our answer is R squared theta. So our shaded region, we subtract, then this is 1 and 2, and so we simply say 1 minus 2. So what will be our answer? It's R squared sine 2 theta minus R squared theta. So R squared is common there. Our R squared is common, so we pull out R squared. Then inside we'll be left with what? Sine. We'll be left with sine 2 theta minus theta. So that is going to be our answer, and we have shown, because the question was saying show that, so we indicate that we have what? We have shown. All right, I hope that one is clear. Okay, right. Then next question is saying, given that R equal 8 centimeters and theta equal pi over 6, find the exact area. So we're just substituting, because now we know the values of R and the value of what? Of theta. So we substitute. We first write the formula. It's R squared. So let's just say you're not able to prove the answer. At least you're going to get these 2 marks. So don't leave out these 2 marks. If you failed to follow solve part, if you failed to solve part A, at least don't leave those 2 marks in an exam. So yeah, right, so we're substituting. So our R is 8, so 8 squared, open bracket, sine. So 2 times pi over 6 is what? Pi over 3. So it's sine pi over 3 minus our theta is what? Pi over 6. Pi over 6. Right, so here we're required to find the what? the exact area of the region. So we're supposed to have the exact answer. So you punch this in your calculator. Make sure that your calculator is in radians. Okay, make sure that your calculator is in radians. So it's 8 squared, open bracket, sine pi over 3 minus pi over 6. Pi over 6. Right, so what is our answer there? Okay, right, maybe let's do it this way. What is sine pi over 3? So that we get an exact answer. Sine pi over 3 is half, and so this is like 64 times half minus 64 times pi over 6. So what happened here is I distributed the 64. So what is half of 64? Half of 64 is 32 minus 64 times 1 over 6. So what are you getting? 32 over 3. So it's 32 over 3 pi. Right, so this one is exact. Okay, so we have our units there. You can just have everything in brackets, square, centimeters. Okay, right, then we're almost done with our section A. We're left with number 4 and number 5. Right, let's go to number 4. Number 4, this is linear law. It's very important when you get a question, you identify the topic that you'll be concentrating on. So this is linear law. Number 5, it's partial fractions. Okay, so by plotting against x, okay, we're given the table of values, and it is suggested that the variables x and y are connected by the equation, that one, where p and q are constants. By plotting y over x against x, draw a graph for the given data. Right, and then use the graph to find the values of p and q. Right, so when you want to draw the graph, and so first thing first that you're supposed to know is since we're drawing the graph of x against, so what I'm going to do here is I'm going to draw the table of values, because with me here I don't have a graph, so we're not going to get the most accurate answer. But if you have a graph paper there, you definitely get an accurate answer, unlike me here. So we're plotting the graph of y over x against x. So let's write our x values are, this is our x values, then our y values will be a y over x values. So our x values, they do not change. We still have 1, 2, 3, 4, 5, 6. Right, then our values, they are changing now. Right, so is that a minus 1? Yeah, that looks like a minus 1. Right, so y over x. So from here, maybe I'm going to show them here. Here the value of y is 1, the value of x is 1, minus 1. So it's minus 1 over 1. So it's minus 1. This one is not changing. Then the next one, 2 over 2 is 1. The next one, 9 over 3 is 3. The next one, 20 over 4, it's 5. The next one, 35 over 5, it's 7. Then the next one, 54 over 6, it's 9. 54 over 6, right, it's 9. Okay, right, so this is what is required of us. So let's quickly draw our graph. So when you are drawing your graph, you're supposed to have a, what do you call it, make sure that you have a ruler. Use your ruler there to draw your graph. Okay, we are going to try to draw a sketch. We're going to try to draw a sketch of our graph here. Right, okay, right. Right, make sure that you use a scale. I would use a scale of 1:1, so that I don't face any challenges. A scale of 1:1 will be perfect in this case. Right, this is my x-axis. Okay, right. So let me label my graph. This is the y-axis, this is the origin, this is the x-axis. So for our axis, we're starting from 0, going to 1, 2, 3, 4, 5, 6. We do the same thing going up. Yeah, so for this one, the y over x is beginning from -1. So maybe let me just increase my line. Let me have the ruler again. I need it here. Yeah, need to, yeah, perfect. Okay, so this is -1. So maybe let me just try to bring it closer like that. Yeah, so 0, or my 0 is there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's good. Right, so my first point is 1 minus 1 right there. Second one is x is 2 1. Third one is 3 3. 3 3 is there. Then 4 5, 4 5. And then 5 7, 5 7. Then the next one is what? 6 9, 6 9. Right. Okay. Right. Let's check our points again. The first one is 1 minus 1. Okay. Followed by 2 2, 2 1, followed by 3 3, followed by 4 5, followed by 5 7, followed by 6 9. Right. So I just want to increase my line there, because I noticed that we are going to need this line going downwards. Okay. Right. Yeah. Right. Now I want to join these points. So you take your ruler, you join your points nicely, making sure that your ruler is passing through the points, through all of your points. Right. Okay. Yeah. I hope that one is clear. Okay, so we've plotted our line. So what we're supposed to find the value of P and the value of Q. Remember, I want to remind you something. Remember that the general equation of the equation of a line is in the form of y equal mx plus c, where m is the gradient and c is the y-intercept. So in this case, our graph is y equal px squared plus qx. So p is our gradient and q is our y-intercept. Right. So what is our intercept? Let's first identify our y-intercept. The y-intercept, it is where the graph is cutting the y-axis. Okay. Right, where the graph is cutting the y-axis. So where is our graph cutting the y-axis? It's cutting our y-axis right at this point. Right at this point there. So if you check roughly, that point looks like minus 2.8 there. So we can just indicate and write that. Therefore, I'm sure you guys will have accurate answers if you're using a real graph paper, unlike me there. So therefore, therefore it's Q1. Therefore, Q is equals to minus 2.8. Right, now we have to find the value of what? Of P, our gradient. Our gradient, you use the points. Even if you use the points on the tape or the points on the graph, because the points on the tape are the same as the points on the graph. So maybe let's use these points, this point and that point, to find our gradient. So those points, the points that are indicated is 0.21 and 0.33. So our gradient, the formula for finding the gradient In this case, our gradient will give us the value of what? In this case, our gradient will give us the value of what? Of P, actually, because of the value of Q already. So P is equal to y2 minus y1 over x2 minus x1. So this is x1, y1, x2, y2. So it's going, our answer is going, we're going to say, what is our y2? We're substituting. Our y2 is 3. So 3 minus 1 over 3 minus 2. So 3 minus 1 is what? Is 2. 3 minus 1 is 3 minus 1 is 2. 3 minus 2 is 1. So our gradient is 2. So the value of P is 2. Then we're done. We're done with number 4. Linear law is pretty interesting. Right, next we're required to show, moving to partial fractions, we're required to show that the right hand side is equal to the left hand side. So for me here, I am going to consider the what? Consider the right hand side. This is number 5. I'm going to consider the right hand side. My right hand side, I'm going to expand x plus 1, x squared plus 2. Right, so x times x gives us x cubed. X times 2 plus 2x plus x squared plus 2. Right, the first one gave us x cubed actually. Right, I think we've actually shown. Maybe let's rearrange, which implies that x cubed plus x squared plus 2x plus 2. So this is equal to left hand side. So we have what? We have shown. Okay, right. Let's go to 5b. Right, 5b was supposed to partialize. Right, this is a special partial fraction. This is a special partial fraction. Why am I saying that? It's a special partial fraction because the denominator and the numerator, they all have the same power. So if that's the case, first thing first, you divide. Don't make a mistake and say, no, let me just tackle this question. First thing first, what do? You divide. So maybe let's start on a fresh page. Right, so 5b. 5b, let us divide. Right, so we are dividing we are saying x cubed plus x squared plus 2x plus 2 into x cubed. Remember this question said and so otherwise. So we'll see how we continue from there. So x cubed into x cubed is 1. So 1 into x cubed is what? X cubed. 1 times x cubed plus x squared plus 2x plus 2. And then the next thing that you're going to do there is we're going to subtract. So x cubed minus x cubed is 0. So here, below here, we're left with what? Minus x squared minus 2x minus 2. This is our remainder. So maybe we can, so our answer is, so we're saying that at the end our answer will be equal to what? So our answer is equal to 1 minus x squared plus 2x plus 2. Like what happened here is I pulled out the minus, then it went to the center, over x cubed plus x squared plus 2x plus 2. I hope that one is clear, right? Of which, let's go back to the first part of our question, to 5a. What were you told in 5a? In 5a, we were told something that is going to help us here. We were told that these two, they're equal to each other. So that is what we are going to do now. So this is the same as 1 minus x plus 1. No, this is what I'm saying. Right. So this one, the one on top will come down as it is, and will come up as it is, x squared plus 2x plus 2 and over. Then the denominator will come down as x plus 1 being multiplied by x squared plus 2. Right. That one is clear. I hope that one is clear. Okay. Right. So we're not done with partializing, because we need to deal with this side. We need to partialize this side. So we're going to say, since we're partializing this side, we're going to say x squared plus 2x plus 2 over x plus 1, x squared plus 2 is similar to a over x plus 1 plus bx plus c over x squared plus 2. Here we used a over x plus 1 because it's a linear function. Then the second one we said bx plus c because it's a what? It's a quadratic function. Is that one clear? All right. It's clear. Let's continue. All right. So then the next part we're going to say x squared plus, it's like we're going to multiply everything by the common denominator. Our common denominator is x plus 1 and x squared plus 2. Okay, so if we multiply the right hand side by the common denominator, we're only going to be left with the numerator x squared plus 2x plus 2, of which this side will be left with a, right, being multiplied by x squared plus 2, and then this side will be bx plus c being multiplied by x plus 1. Okay, right, maybe let me explain again. So what happened here is we multiplied everything by the common denominator, which is x plus 1, x squared plus 2. So if we do that, what will happen is this one will cancel there, then this one will cancel there. So that is why at the end we're left with that. I hope that one is clear. Right. So we did the same thing to the right hand side. So if you multiply this x plus 1 by the common denominator, which is this one, these two will cancel, then we'll be left with what? With x squared plus 2. Same applies here. If you multiply this by the common denominator, so these two will cancel, then we'll be left with what? X plus 1. So that's what happened. Okay, so now we are partializing. So first thing first, when x is equal to minus 1, when x is equal to minus 1, what is going to happen? When x is equal to minus 1, this whole thing will become 0, because 1 minus 1 is 0. So everything here will become 0. Right, what about left hand side? Let's take our calculator. Minus 1 squared plus 2 times minus 1 plus 2. Left hand side, we're left with 1. On the left hand side we have 1, which is equal to, then on the right hand side, 1 squared plus 2 is what? Is 3a. So a is equal to 1 over 3. Okay, right, and then the next part, maybe let's let what? Probably let's let x, when x, let me see. Probably let's let x be equal to 0. When x is equal to 0. So when x is equal to 0, what's going to happen? On the left hand side, we are going to be left with 2. 2 is equal to, then this side, 0 squared plus 2 is 2. So you are left with what? 2a plus, then b times 0 is 0. 0 plus c is c. So c multiplying 0 plus 1, we're left with what? 2a plus c. But now we know the value of a. So 2 is equal to 2 times 1/3 is what? 2/3. plus c. So what is c? C is equals to 2 minus 2/3. So what is 2 minus 2/3? 2 minus 2/3, we get 4/3. So c is equals to 4/3. That one is clear. Good. Right, maybe let's just underline our major answers. Right, so what so far the next thing is want to find the value of what? Of b. Maybe when x equal 1, let's say when x is equals to 1. So 1 squared plus 2 times 1 plus 2, what are we getting? We're getting 5, which is equals to a, open bracket, 1 squared plus 2 is 3. 3 times a is 3a, plus 1 times b, what are you getting? We're getting b plus c, then 1 plus 1 is what? 2. So we have 5 is equals to 3a plus 2b plus 2c. Right, so far we have the value of what? Of a and the value of c. So 5 is equal, going to substitute. So 3 times 1/3 plus 2 times b plus 2 times 4/3. We have 5 equal 3. 1/3 of 3 is 1. Then let's go it like terms, plus 8/3 plus 2b. So let's just bring everything to the other side. 5 minus 1 plus 5 minus 1 minus 8/3 equal to b. So 5 minus 1 minus 8/3, what are we getting? We're getting 4/3. 4/3 equal to b. Then we divide by 2/3. So b is equal to 2/3. So therefore, what is our answer? Our answer there, we now know the value of a. So our answer is 1/3 times x plus 1 plus our b. Our b is what? 2/3. 2/3 x plus our c, which is what? 4/3 of x squared plus 2, of which we can simplify this. So it's 1/3 x plus 1 plus 2x plus 4/3 x squared plus 2. Right, let's not forget something, that our answer should be in that form. Right. So here where I have a star here, that is what I am the answer that I got there, I'm supposed to replace it up there. So the final answer, therefore the answer is 1 minus, I open a bracket, because that minus is affecting everything. It's affecting everything that is following there. So it's 1/3 x plus 1 plus 2x plus 4/3 x squared plus 2. Right, the end. We are done. That is our answer. So we have come to the end of the video. Please feel free to add. If you have any contributions, feel free. This is our channel. We're all learning mathematics, and with mathematics, errors, we are prone to get errors, but practice makes perfect. So let's meet on our next video, when we'll be concentrating on section B.